So this is a program that was launched by Google 2 days back, and so you've all heard of something called a UI designer. A UI designer basically designs your task from 0 to 100, and all the web applications, your mobile applications are built on this type of UI that you will create. So now say I wanted to create something like a website, or I'll just pick a prompt from here. So they're saying mobile friendly home for a marketplace, handmade ceramics, pottery. This is just an example. So first of all, we'll replace each of the engineer that's part of the process, and you'll see that most of that task can be done in a very streamlined manner just by me within 5-10 minutes. So if I'm able to do all of that right here, all of those engineers that we are preparing as that, okay, this is your niche skill that you become an expert on, you just become a UI designer. Eventually, maybe that UI design project becomes, maybe the UI engineer is not replaced, but the UI designer only needs to be one very intelligent person, a one very experienced person. So why would I hire a younger engineer, a new engineer who is not very experienced in the field? So for example, within a minute, we have this mobile application. This is a very simple display. If you give it to a UI engineer, they'll maybe take 1 or 2 or 3 days to do this. The next thing I do is I copy this on Figma. Figma is a very popular UI design website. Let's see, I'll just go there. Maybe I'll just start a new design project. So Figma is a software normally used for prototyping. So I had copied something from that website and I'm pasting it here. Wait, it's not. That's still being copied. Allow. Copy to Figma. Okay, so it's right here. I will basically, my purpose was to create a link that I can copy. I go and open my coding software. So this is Windsurf. There's quite a few of those. These are your normal. They've converted your normal coding software into AI coding software. So you, for example, I open anything on my desktop. I'll just make a new folder. Say it's a design new. I start here, opening it. Okay. I just go and choose that I want to use Figma. I put that link that I had, and I'm just gonna say, hey, can you make this into a white web app? White is a common framework to build applications, and then I say and deploy it also. So now it's going to take that UI design and itself finish that whole process of making that website. This could be a mobile application, this could be a web application, and eventually this was done in a very rudimentary fashion. But while it does it, I can show you that so we had thought of a new project that we were doing within our software development lab, and so this is an application that I built. This was done by myself in 3 days, and it has around, all of these files, and each of those files would have 500 lines of codes, and all of this was done within the last 3 days. There's some errors that I'm trying to solve, but all of this is very quickly done with AI. And anyone who's involved with this process right now would know that this is something that used to take days and days. Like if I wanted to build something like this would take a week. If I wanted to build something what I built in the last 3 days, that would have taken months, like 4 months, 5 months to even get to a prototyping level. So all of that is completely gone. So that is the first point that we have to note. But what is the positive side of it? So the positive side of it is, since the copy pasting part is gone, you now become an engineer who's really an engineer. And what is a real engineer? A real engineer solves a problem. A real engineer is not a copy pasting machine. So an example that we can take from, say, back in 1700s, India was a very popular cloth making industry. So in Dhaka, in Calcutta, in Bengal, there was a huge industry where people were making muslin cloths, and it was considered very soft. It was considered very high quality cloth, and people around the world, Portuguese, British, French, they were all coming here to trade in that, to trade in the quality manufacturing that we were doing by hand. Within 100 years of that time, they had developed steam engine. From that, they had developed factories. Those factories could make those fabric within days. If something would have taken by handicraft, handwork, days and months, this would take an hour, 1 day to get that manufacturing done, and the cost of that manufacturing went way down. So India's whole manufacturing industry had evaporated within a year, within a decade of the time, and that was back 200 years ago. So things were slower then. It'll be the same now, which is you don't need people to make those clothes anymore. You need to make those machines that make clothes. So what I mean by that is, so people like me, people who are involved with the field now, what they're doing is that we are making agents. So you'd hear this on a lot on Instagram these days, and whenever if you scroll and you'll see that a new AI agent came that can do this. So what does that mean? That basically means that your chat GPT, your large language model, you pick your large language model and you connect some hand and leg to it. So if you wanted to do, so for example, I wanted it to look at the Figma URL from that website. So I just connected that Figma to it already beforehand coming here, and it could then go and look at that website. There is it in a very structured way, and then of course it already knows that once I've looked at it, I have the brains to do this specific thing. So it has the brains. You attach hands to it, and it can basically do that task. So these are called agents. So what will happen in the future is, say this is a robot, and what we are trying to do with it is, so this robot is it's just a mixture of motors. So when it moves a hand, it has a motor here, it has a motor here, and it just moves things like that, and it can move things like that, and it is just a bunch of motors stuck together. And we can, so then what do we do as an engineer on it? If I want to make it into an intelligent machine, this chip on the top of it, this is an NVIDIA Jetson chip. So that's where it's the main GPU of this whole thing. So this brain is currently only instructed to do some specific tasks to it. So this is something that's already fit in. Like the manufacturer has said, ki, when I click this button, you do this. So this is something that's fixed. Now, what would it do if we were to put an agentic mind in it? So if you put in, say, imagine a ChatGPT LLM inside of it, and you say, ki, go and shake your hand with that person sitting there. So then first it has to see you through the camera, realize that you're sitting there. Then it goes to him, recognizes that that's a person, and then shakes a hand. So that's a whole process that only a human could have done till now, which can be done now with an LLM. So as an engineer, what I do is I put that brain in it, that you have the LLM, and that LLM controls all these motors in it itself. So that part is something that has not been done yet, and it's very complicated to do, and that is where the brain comes in. So another example, which would be easier to understand, there's this huge industry in India that's booming right now. The government is also pushing a lot. There's a semiconductor industry. So we know, like, so for, Apple had made a huge factory down in Tamil Nadu. Trump is trying to take away, but if Apple goes, Samsung will come. There's huge number of companies that have come now. Foxconn has opened with HCL in Delhi. There's a lot of semiconductor companies that have opened. So semiconductor companies are your manufacturing companies. So whenever if you've seen an iPhone or a Mac, there's a line written behind it which always says designed in California and made in China or made in Taiwan. So that basically means we have designed it down to the chip level, and you basically manufacture it in China or Taiwan. But what is the bigger company? The TSMC company that's manufacturing in Taiwan, or Apple that's just designing it? They don't manufacture anything. Which is the bigger company? Obviously, we all know Apple is by far probably 10 times bigger than TSMC on that product, just by that product. So that shows that even if you bring manufacturing into a country, even if you have access to easy manufacturing, cheaper manufacturing, you need the designing part. You need the brain behind it, like how that would be made. So then we come to how will the chips be designed. So we already have the chip manufacturing now in India. How will we design those chips? How will we make the chip as Intel did, or Apple has its own chip with ARM, or whatever, like Qualcomm or other companies that are making these chips? How do we design those chips? So then I need to start a company that does chip architecture. So what is a chip architecture? So there's a lot of different types of architectures. So the current Apple architecture is used by a company called ARM. They used an architecture called RISC. Intel used to do something CISC. But that's basically different types of architectures with these companies that used to play with. Now, if I want to start a company like that, I would need to hire, say, 500 or 1,000 electronic engineers who would need to sit down and program that chip with me for 5 years. And it would be that 5-year long process to get to that level where America is already there, where Intel is already there, where UK is already there in a decade back, where China is already there. How do we compete with that? We compete by not hiring those 500 engineers, but instead we hire 10 good computer engineers who come with me and train agents, who train that factory, that agent that can actually become that electronic engineer. So if we can design these websites, which is an easy process, why can't we design those chips? So there's a thing called RTL engineer. This RTL engineer is what works on the hardware of the chip. So replace that engineer with your AI agent. Who will do that? The computer engineer will do that. So if I want to start a new chip company, a chip design company, I don't have the money to hire 500 engineers or 1,000 electronics engineers that a big company like Intel would have. What would I have is I can hire 5 or 10 very good computer science engineers who sit with me, and we'll sit together and train AI to do that work for us. So this is what the future of computer science would be. That if I am a bioinformatics company, I would want to hire a computer science engineer who knows both bioinformatics and computer science. If I want to say build new types of materials, I'm working on batteries, lithium ion batteries. You have your magnesium ion batteries. New batteries will come. Everything is surrounded by electric cars, and your drones. You've got your phones. Everything is batteries, and they have to be made better. That's material science. Again, if I hire a material science engineer, it would be the same process, 5 years, 10 years to make a new material, to test a new material, 6 months, 1 year, because a human has a inbuilt a threshold of that capacity, because we have a set of information that we can do, that we can research on. And of course, we'll be in that process, and we have always been in that process. So one way is hire 1 lakh material scientists, 10,000 material scientists, or train one AI to be as good as 1,000 material scientists. So who would train that one AI? That would be computer scientists. So the future of computer science is exactly this, that computer scientists will not become coders, but they would become these architects of these AI products, architects of these multi-agentic systems. You would connect one AI to do this, one AI agent to do this. Maybe in this robot, one AI agent to see, one AI agent to move the hand, one AI agent to process what to do. So maybe we can replicate our brain, which is a very complex brain, into 100 AI agents put inside of this brain, which act exactly as my brain. Like, we can't really transfer my brain to it right now, maybe not for the coming decades, but what we can do is create 100 agents that can do very good, simplified, different tasks, and then I connect that process. So this is what is happening in, this is like a very, currently the most booming field in AI and computer science, that connect a lot of agents together, and this is something that's still unsolved. It will be in the next 6 months. Google is trying to do this. So these are the things that are going to impact the future of current computer science students who will join this field. So when anyone joins computer science today, it's not really a big matter that I want to specialize in, say, DevOps engineering. I want to specialize in DevOps engineering will not exist in a year. I want to specialize in front-end engineering, in back-end engineering. All of that would be a very limited job, or it will be a dying profession. How do you succeed in the future? You train yourself to become a multi-pronged engineer. You try different fields. You go for robotics. You go for material science. You go for bioinformatics. You become the professional of designing the architecture of that product. And once you have the capability to do that, then you become that hireable person for the people who will be hiring you in 4 years. a startup in 4 years will not be hiring hundreds of students or in placements. They'll be hiring 4 or 5 only good engineers. Because what I want today is that I want this product to be built next month, and that product has to be built next month. So I would go for only seniors who already know how to do it, rather than hiring interns or people who don't know how to do it. Because this can do a job of intern, this can do a job of a new dividing the copy pasting task. So all of this is replaced. So you become someone who is multi-pronged, who knows how to design architectures rather than just copy paste code. You become someone who's able to find solutions of problems. And then maybe in a few years, already while you are in this degree, in the next 4 years, 5 years, you become a senior of a specific field. So why waste these 4 years into becoming something? A lot of engineers come and I see them where after 4 years of your degree, mostly no one knows anything, and then they are getting these jobs in TCS, and after 4 years in the industry, then you would say that okay, this person is 4 years senior, but you already have the 4 years passed from your 12th degree. Why not have those 4 years counted as your 4 years seniority? If say for example, if you are a researcher who has done a PhD, so you always say that say you've done, like you did your PhD 2 years ago, so you would say that I've been a researcher for the last 5 years. But that is not the same for computer science engineers. They never say that I have an experience of 4 years or 5 years when they're passing your degree, because they know that they have not done that type of work within their degree, which is very easily possible now. So the faculties have to be aware that this is changing. The students have to be aware how it's changing, and then take it to your advantage. If you know how to build the latest things with your advantage, you can already start doing startups within your degree. You can already start finding solutions. And to end it on a very positive note, it is very clear that 100 times more software will be built because it's become very easier. So 100 times more software will be built in the next 5 years. 100 times more apps and applications. There'll be software for every small thing, and there'll be solution for every small thing. It'll become very competitive to make your software succeed, but also that also gives a good opportunity that engineers, there'll be more jobs, there'll be more possibility for people who know how to solve things. There'll be more possibility. If you're good, you'll have more options. If you are good, then a single person can start a $1 billion company, or at least $1 million company. If you are good, 3 or 4 friends will be able to build companies like never before. So this is a great time to be a computer science engineer. It's probably the first profession to be attacked in this way. Like the first thing that AI replaced was a coding engineer. But it also is the opportunity for a computer science engineer to lead the world in the future, because everyone else can be replaced by AI, but who will make the software that will replace them? The computer science engineer. So it's a very positive time to be a computer science engineer. But you just have to choose wisely. The faculties have to be very aware of what is going on, and choose a college or a university that is able to give you that platform, or at least be able to explore the opportunities, like playing with robots, playing with your multi-agentic systems, from far off fields, from material science to your even civil engineering, even smart planning, all the types of fields that are very easily accessible to you now as a computer science engineer. Everything is. So in conclusion, very positive time. Just choose wisely. And if anyone has any question, they can definitely ask me now. Or Aditya sir can share my email ID and phone number if anyone wants to know anything. Thank you so much.